Hi. So we're going to see how this two mics thing works.
Yeah, what's up?
I'm Jess.
I'm Mollie.
We're both data scientists with Datascope, which is a data science consultancy. And we work with a lot of different kind of clients across industries to come up with creative approaches to data problems and create custom tools and visualizations.
Right, so we're going to pull from our experience to impart what we found works for getting your point across, the art of choosing the right visualization for your data. So our agenda for today, we'll talk about first the most obvious question, why do we visualize data? We'll go through some fundamentals because we find that it's really important to know the basics so that you can choose between the options. Talk about some storytelling techniques for when you want to do something more complex and compelling with your data. We'll go through the iterative design process because it's what we found to be a really effective way to quickly hone in on what's important when making your data visualization. And then we'll go through a case study to show iteration in action and to tie everything together. So, Jess, why do we visualize data?
Well, I say the most common reason we visualize data is the kind that's most often overlooked. And that's because we don't really intend to share it. It's what you do when you explore data to get to better questions and to figure out next steps. Take this Anscombe's quartet. It's a pretty famous set of data. And that's because these 4 sets of numbers actually have some interesting properties. They all share the same summary statistics, but underneath they have very different underlying patterns. Figuring that out just by looking at these numbers, though, takes a lot of mental work and time. But throwing them up visually, you can see right away that they have these differences, and then you can figure out how you want to treat them. It's a great example of how visualization can help you make better decisions faster.
Right. So the other main reason of why you visualize data is to tell a story. It's when you want to share particular insights or conclusions to your audience in a way that's much easier to digest than if you just threw them a table or wrote it out in Word. Something to be careful about here is it's really tempting sometimes for people to want to give their audience all the data, just like, here it is. See all the cool things, but that could be really overwhelming. And so it's really important to find what are the main insights in your data or what's the main story that you're trying to tell and craft your visualization around that.
And something that we have found in our experience to be really critical in crafting a good visualization is a real understanding of some visualization fundamentals, as well as understanding the trade-offs that you make when you're deciding between different choices or going with one option over another. And actually being able to articulate some of these trade-offs can be really essential in making informed decisions yourself, but it's also really useful when you're working on eliciting useful feedback from clients or from others in getting to a better visualization in the end. And of course, context really matters because the exact same choices either succeed or fail based on what you're presenting to whom and for what purpose.
Right, and in order to make choices, it's really important to understand like which type of visualizations are better or worse for which type of data. So we're just going to quickly kind of walk through just a few kind of basic examples and talk about why these visualizations are really good for some things or for others or not so good. So because of the mass amount of geocoded data available nowadays, it's really popular for people to want to put their data on a map. And although that's all well and good, you have to be really careful when you do that. For instance, if you just take this comic showing 3 totally different things thrown up on a map, you see that next to each other, they basically look the same because what this is really showing is population density.
Right, and this is why when you're dealing with geography and really just any data that's tied to population, you want to do things like normalize for population. But really what's even more crucial to a good map visualization is making sure geography actually adds to the story. This is a great example by John Nelson where he visualized 5 years of drought data, and putting it on a map is something that really drives home which areas have been most impacted by this phenomena. And it's something where geography definitely matters to the story.
Right, another chart that tends to get misused and hated on quite a bit, but I would say hated on for good reason, is that is pie charts. And the reason is too often people just want to throw a plethora of information into a pie chart and have a lot of different pie pieces. And as I heard a few people say yesterday, and I will reiterate, that is really hard to read. It's hard for the brain to really make sense of these things. As far as pie charts are concerned, like they can be useful sometimes, but really what the eye's really good at with seeing in pie charts is straight lines, 90-degree angles, quarters, halves, things like that. So this one, for example, it only has 2 data points, which is good for a pie chart. And I can look at this and immediately see, oh, most people think of Michelangelo as a Ninja Turtle and not as an artist. Right. It gives it gives a general picture.
Another visualization that is really simple and effective is the bar graph. It's one of my favorites. It's really great at conveying one or a few messages. It's also really handy when you're dealing with categorical data. But just like good pie charts, it really takes advantage of the fact that the human eye is really good at vertical and horizontal lines. I flipped that. But because of that, when you put data in a bar graph, it's actually really easy to tell the difference between what's going on, and it's easy for you to interpret. And really, I think the main reason that a bar graph is good, though, is because of how ubiquitous it is. You don't have to educate your audience or the end users of your visualization in how to read a bar graph. I mean, you've seen it so much, you know what to do, you understand. It's why we love histograms when we explore data. It's why so many of our clients sometimes prefer a bar graph to a really complicated visualization option when we give them both options. Bar graphs are great.
Right, and speaking of things that are pretty straightforward and that a lot of people are used to reading are the line chart. I just want to make a side note here and mention that you've probably noticed that we've used a lot of XKCD comics, mostly because we think they're really fun. But also, Randall Munroe is amazing at data visualizations and actually won an award for data visualizations this year for the Earth Temperature Timeline comic they did. So just a side note to give props since we're using a ton of them. Anyway, yeah, so line charts are really good for continuous data, and they're really good for showing correlations.
But you know, regardless of the kind of visualization you end up going with, it's really easy to unintentionally create a lot of visual noise and clutter. And so you want to be mindful that the main reason that we're doing a lot of these visualizations is generally to make things easier on the audience and to make it easier for them to figure out what's going on and to follow along. And that's why it's really important to edit and revise yourself all along the way and not just at the end. You want to ask if what you're doing is actually adding or contributing or getting in the way of your message. Something that can really help you do that, though, is to make sure you don't do this kind of revision all in a bubble. You want to get feedback from other people because they're going to not only be able to give you solid suggestions and direction for what you might want to do better, but actually getting to see how another person interacts with your visualization and whether or not they're asking certain questions or get what you're trying to have them take away. It's all invaluable in figuring out how you can make a better version the next time and really get to the final good end product. And of course, now that we've really harped on how important it is to keep things simple and clear for your audience, we're going to also say that sometimes it's okay to do a more complicated visualization, but you want to make sure that there's a reason that you're choosing to do so. Either you want to make a more compelling story, so something more complex is going to help you do that, or possibly you're dealing with a really rich and complex data set that you don't want to take away any of that complexity from. And in fact, the complexity is what you want to highlight. And same thing as what works in a good novel, like with a clear narrative and a story arc, it can help you really ease your audience into a more complicated visualization.
Right, so we're actually going to walk through 2 different examples of some visualizations that we think are pretty cool for some different reasons that are much more complex than what we've already been talking about. Both are from New York Times. So this first one is Kevin Quillin and Graham Roberts decided they wanted to compare all the Olympic medalists through time of the men's 100-meter sprint. So if someone brought this data to me and just said, here's the finishing times of all the Olympic medalists, show it. Okay, the most simple way to do that would be throw it on a scatter plot, you can see pretty clearly that there's a general trend that as time has gone on, people have gotten faster. But Kevin Quillin and Graham Roberts decided to do something a little bit more complex, and they put their visualization into a video, which you can Google and find pretty easily. It's kind of neat, it's only a few minutes. But they basically reframed the problem instead of, well, they reframed the problem into basically thinking about it as putting all of these medalists, all these people who have won this race in the past, putting them all in the same race. Now, of course, some of these people have long passed. Some of them won a medal in the late 1800s. But if you put them all in the same race together, where would they finish? And that one thing it does is this takes these people and it makes them people again rather than data points, which makes it a lot easier to relate to. Another thing it does is, so people tend to have a hard time really wrapping their head around like milliseconds. Like, at least that's harder for me, and I think for most people to.
Me too.
Yeah, to wrap their head around that. It's a lot easier to think of things in like meters and in distance. Mm-hmm. And so looking at this, you can actually see like, oh, that person would have finished behind this other person. It also allowed them to be able to point out really interesting things, like, for instance, Usain Bolt. He is actually the fastest man to live as far as the 100-meter dash is concerned, because if you put him in a race with all these people, he would still win. So that's pretty interesting. And they also, because of the way that they presented this problem, there's a lot of potential for layering and pointing out a lot of different things without making it harder to understand. But to see what I'm talking about, you can watch the full video sometime. So I'll hand it over to Jess for another example.
Right. And this example actually deals with the whole concept of a really rich and complex data set. It's something that Amanda Cox and Nate Kahn did, but I'm going to point out that they did something really smart. They didn't just show you this really big, complicated visualization like I'm doing right now. This is pretty terrible.
Yeah, I have no idea what's going on.
Right. Instead, what they did was, first of all, they introduced the idea and they eased the audience into the big visualization. This was all about the voting habits of Americans, and the goal was to really highlight the different, just how increasingly divided the US electorate is and how deep the fissures are getting, which I imagine is just getting more and more interesting as each week passes. But anyway, in the end, the visualization shows 8,000 groups. In order to make you able to understand this, I'm going to actually go to the visualization itself. What you see once this loads.
Hopefully.
Yep. Well, the whole point was, at first, they introduced the idea, but then as you go in, they're layering each piece of information and each layer of demographic information one at a time. And it's a blank screen. This is a great visualization. Isn't it impactful?
There we go. We got it. We got it.
Okay. So essentially what's going on here is that they give you one piece of information at a time. First, they give you the big picture, like what's going on in all of US. Sure, something you can follow along. And then as you scroll down, they add all those layers I talked about, building one by one and adding more complexity to the picture. I'm not going to go into all the details of what's going on. I just really want to highlight the animations that they use, because this is a really effective use of animations as opposed to just decorative. And the reason it's really effective, as I go up and down, what goes on is that the next picture comes into view, and it builds on the previous stage that you just saw. This allows the audience to mentally follow along and themselves deconstruct and construct how these groups make up one another and how you can go from a picture of the whole US to all those 8,000 groups in the end. And at the bottom, that is the only point when they actually invite you to go to the big complex visualizations that I pointed out. The key thing there was that they also gave you a primer, which was served as a kind of instruction for how you could learn how to use this visualization. They said, find yourself in the graphs. I mean, without that, right away, like, we're all a little egocentric, so we're going to go ahead and just like look for, you know, where we are. Oh, that's not me. But essentially, you go in and you see how adult women are doing who have college education, let's say Well, Nevada. I'm not in Nevada, but let's say we're in Nevada. You could see where you yourself are, but then you also have a sense of how you could then explore and use this tool to find other patterns, maybe find your friends or your family or people that you completely disagree with or think that you have big disagreements with. And it's a great way to then understand the complexity. And the other thing that I want to point out about that is that just like a great novel, if I just give you the last chapter of The Count of Monte Cristo, even if you can decipher and follow along, even if you understand everything in this visualization, without all those other pieces that came before it, it's going to have a lot less impact and power if you don't lay that kind of context and introduction.
Right. So,
I mean, it's also something that just doesn't happen right away.
Right. So basically, I'm going to back up. Here we go. Got it. You're not going to be able to just sit down. Like, if you get a new data set, you're not going to sit down and just be like, cool, I'm going to make that thing. Like,
right.
That takes a lot of steps to get there. In fact, it is pretty much expected that the first few things you make are probably going to be crap or maybe going in the wrong direction. So
it also takes a lot of practice, and that's something that's really important. The first few times that you try to do it, it's going to also just kind of be a clunker. So you want to make sure that you go through that process, and the iterative process helps it be approachable, so it's not a daunting task.
Right. So I'm just going to talk for a second about the iterative problem-solving process and how that might apply specifically to data visualizations. So when we start any project, it always starts with generating a lot of ideas, some sort of brainstorming. And I'll speak specifically for data visualization. In that case, it would be basically a sketch session where you sit down with, I'm talking pen and paper, like no coding yet. Pen, paper, or pencils, or crayons, whatever your weapon of choice is, yeah. And creating as many sketches as you can think of for this particular data set, for the problem, for what you're trying to show. And it's important to put down not only your good ideas, but your like the ideas that you're like, this probably isn't that great. It's still important to write those down because a colleague that you're also sketching with might see that and be like, well, I have something to build on that. And so that's also really important. So generate as many ideas as you can. In this case, this is the prototype. So once you've done that, you're going to want to evaluate these sketches, these prototypes that you've come up with. And that might be that you're talking to your teammates and getting feedback, or if you're at a consultancy, it might be that you're showing it to clients and kind of explaining to them like what the different plots stress, what they're good for. Right, and figuring out where they want to go. But then even once you've kind of narrowed down to one specific visualization you want to focus on, you have to do this all over again. There's a lot of other things to figure out. You're going to have to sit down, have more brainstormings, generate more ideas, build more prototypes, more evaluation. And by doing a lot of low investment experimentation and really quick iterations, and then getting feedback, you can figure out what's working or not for your visualization and really come to the end product that's most valuable to you.
Yeah. And to show how it all comes together, we're going to go over a visualization project that we did recently with Datascope. As some backstory, the US is really pushing to improve STEM education in the US, as we should. And Code.org is a great organization. They're a nonprofit that's working to help make this happen by providing resources to teachers and schools that are working to incorporate computer science education into their curriculum. Fun fact, Obama actually became the first president to write a line of code by participating in one of their Hour of Code programs. This is his first line of code. Very, advanced, but anyway, back to Code.org. Like I said, they're working to help a lot of schools out, and like a lot of nonprofits, it's really important for them to figure out if they're doing a good job at what they're trying to do. And so they reached out to Outlier, and Outlier developed a series of studies and surveys to help them evaluate how they're doing. And Outlier reached out to Datascope because they wanted to create an exploratory visualization for the general public that could hone in on a specific subset of the survey results. What we together decided to work on was a snapshot of students' opinions prior to exposure to the Code.org curriculum. And the question that we focused on was, what is computer science? And Mollie?
Right, so it turns out the students did not have a agreement on what computer science is. This is a very small sampling of 3 of thousands of responses we got. And when they vary so drastically, it's hard to have a conversation about computer science. Right, so we had, there were all these different responses, and Outlier grouped them into categories and came to us with these categories, these responses, and as Jess said, wanted that to be visualized in some way, but they didn't know exactly how to go about that. But often that's how it is. The client typically, doesn't have a set idea, yeah, which is almost better sometimes. So we did exactly what I talked about earlier. We sat down, we had a brainstorm, we sketched out as many ideas as we could, the good and the bad, and presented them to the client and showed them what would be better or worse, or what would be stressed or not stressed by different visualizations. And so what we're going to walk through next is the actual sketches that we sketched out. So these are just like pen and paper and marker and stuff that you'll be seeing coming up.
Right, and like we said, we wanted to see what was going on in the survey responses. So one of the first things that we thought of was the good old bar chart. Love that guy. It's really easy to group people by category in this way and then make comparisons among them. But we also thought about how we might be able to represent subgroups using bar graphs. Maybe they'd pop down on a click, or maybe we do some sort of stacked bar chart with different patterns, or maybe on hover you would get a little bit more information that would pop up where you can get more context, maybe some keywords, some other ways to explore the data. We also thought about taking a step back and doing something like a ribbon bar where we could see everything on a bit more of a macro scale, just high level what was going on in the data.
Maybe we'd want to group the responses into these bubbles, which, and then show the subgroups by different patterns. And as we talked about earlier, circles are not the easiest for the brain to understand, but we thought, well, it'd be fun. We'll write it down anyway, because that's what you do. You write down all the ideas. Also, basically the same thing in boxes, because maybe that'd be a little bit simpler for comparison. But. Oh yeah, and then also tree maps. Although I don't really love tree maps, I think they make comparisons pretty hard. But in this case, it would emphasize the fragmented nature of the data. And the cohort view, we called it that because every single student here would be represented by a dot. And then the different categories would be represented by different colors. So this also, it's harder to show comparisons between the data here, and it's a little messier, but, or not messier, but noisier, I guess. But what's good about it is it would give individuality to the students and really show the size of the study that was done. Oh, and we thought about how to separate subgroups as well.
We also decided to take a little step away from the whole idea of categories and subcategories and also just explore what was going on within the responses themselves. Maybe we wanted to see the words that came up most often, or the adjectives that people used, or maybe the proper nouns. Yes, a lot of people hate word clouds, and we don't really love them either.
Because they're overused, but.
Yeah, lots of reasons. But essentially, by getting these kind of ideas in front of the client, you can figure out if it's important for them to have this kind of information, and then you can come up with better ways to do these kind of representations that might have more analytic value. We also thought about looking at how often certain words co-occurred together. Maybe learning and teaching was its own group, and something that talked about angry birds and games was a whole other. We also thought it'd be fun to kind of visualize the punctuation that was going on. Were there lots of questions or strong feelings? Or maybe the kids nowadays, all they do is talk in emojis, and that's something that would be really fun to visualize. Yeah. We want to see how many happy or sad faces is going on in these responses, and it would be really fun for an external general public. But we also asked the question of figuring out if the specific responses themselves were really important. Did we want to see the raw data itself? If you clicked on a category, would you want to see all that raw information? Or would you also want to know if it was positive or negative? Did the sentiment really matter? These were all the kinds of questions that came up by presenting these options to our client. and then we got really invaluable feedback.
Right, so upon showing all our sketches to the client and having a conversation about all of them, we learned a few things. First of all, you saw us talking a lot about subgroups earlier because we were under the understanding that the way the data was set up, that there were subgroups. Turns out those were not subgroups, they were something else. So it was just valuable for us to know that, and then we didn't have to think about it anymore. We also found out what they really wanted to stress. So the things that were important to them were to really have the individuality of students shine through, to be able to fully show the size of the study, like how many people took this survey, and the individual responses and the uniqueness of them.
And because of that, the blueprint that we went forward with was the cohort view. There were still a lot of things to figure out. How are we going to incorporate individual responses and the like, but that's where we got to prototyping higher fidelity versions.
Right, but even at that point, like we mentioned before, there's constant iteration, and so this is the first thing that, well, so I'm going to switch gears. Before, what you were looking at was paper and pencil. Now we're working in JavaScript and D3 for this, and this is nowhere near the final product, obviously, but it was important to start showing the client things that we're creating immediately to find out like what they don't like, what makes sense or doesn't. So like we immediately found that having it in a grid like this is not very personal. It loses the touch of those being representing people, and they wanted it to be more like a crowd. So that was one of the first things we noticed. Also, they didn't like that the dots weren't filled in. They said it was hard to see the color. So filled that in. Also, you'll notice that every single slide has different colors because it turns out it's really hard to find 26 colors that, for a group that like don't look like each other some of the time. Every slide, they're different. We eventually came up with something that worked well.
Yeah, I think we struggled with readability and just making sure that it was really understandable all along, visibility and readability.
Right, so at this point, we wanted to show them the different ways that we could show the quotes, the actual responses from the students. And so this we did just using a PowerPoint. Sorry?
1 minute.
Yeah, I got it. So this we just did using a PowerPoint because we didn't want to spend time implementing this if we didn't know which way to go. So one was that we have an expanding categories that would show maybe the top 5 responses, or maybe we have them slide so that people can just click through. Or rather than having them be expandable, what if they just pop up over different dots or different students? And so the first 2 were really good at letting the audience have control over what they saw. The third was really good at furthering the individuality of the dots, but it took away the audience control.
In the end, this actually is live, so you can go ahead and visit it if you like. But what we ended up coming to after a lot of these kind of iterative cycles was something that really highlighted what our client wanted to highlight in the study. It also presented things across different cohorts and groups so that you could explore that easily. And as you can see, we did go with the pop-ups, although we had to play and tinker with exactly how to implement that. There took a lot more iterations that we didn't quite include in this talk, just for time's sake.
But even so, I'd like to just comment really quick that as far as iterations go, like this was actually a pretty straightforward project. They're usually a lot messier than this.
But the iterative process definitely helped us get there, and something that's important to be able to do these kind of iterations and get the kind of valuable feedback you need to get to these kind of good results is to understand the fundamentals and the trade-offs that you make when you're choosing between them. And you need to be able to be flexible and iterate. You have to be comfortable with like letting go of certain ideas if they're not working and moving on. And really using feedback and context and audience to guide how and why you're making the choices that you make.
Thanks, guys.